Okay, hello everybody. Let's get this thing started. So welcome to today's webinar on the topic of how to use 3Dsurvey's new RTK Videogrammetry. So let's get right into it. Today with you, my name is Vit Peterman. I'm vocal supporter of drone photogrammetry. I've been working in this field since 2011, so I might actually look a little older than in this picture. At 3Dsurvey, I worked on more than 1,000 projects involving different photogrammetry aspects. Each of them was exciting in its own way. Since 2011, I also serve as CTO at 3Dsurvey, where I have the pleasure of working with a group of devoted specialists in developing new photogrammetric approaches. I'm also a trained drone operator, so I had the pleasure to work with this exciting technology, and I also have some ability to share with you some interesting insights in how to best capture photogrammetric data. So today with me is also my colleague, Matija Zupan, whom I will allow to introduce himself now. Go ahead, Matija.
Hello, everybody. Today I have some webcam problems, but I'm still here with you. So as you may know, I'm in fact an engineering geologist and have joined 3Dsurvey as QA manager. So my job here is primarily to look over the quality of our releases. That means I do a lot of testing. Every new release gets to be tested and is looked over for bugs and any missing features. So that's why you get better software every version. I have also done a lot of photogrammetry project, and lately I'm very enthusiastic about videogrammetry, so that's why I'm very excited about this webinar today and what we will all learn. So back to you, Vit.
Thank you, Matija. Okay, today's program. As usual, first we will have a little bit of theoretical introduction and we will look into why use RTK photogrammetry. How did we get to this point? Then we will present some general instructions for video recording, so how to record videos to get best results. After that, we will look into how to process this data in 3Dsurvey. So we will look at a general processing workflow from importing the video to what kind of results we get. Then we will look at some further examples of videogrammetry projects, so 3 or 4 additional projects to see what we can expect from it. And finally, we will also look into instructions for installing Videogrammetry Android app and how to set it up to work perfectly. Okay, so why videogrammetry? So we first received the idea to use video instead of photos when we were trying to make 3D models of buildings and some things where we couldn't fly the drone from photos. But we very quickly realized that we are not very good at recording photos because for example, we failed to get a good enough overlap. So we started to test by recording videos first and then extracting frames from video with a certain overlap. So as results, we then get point clouds, full 3D meshes, and maybe even orthophoto if we have enough of top-down photos. Now, let's have a look at our introduction video. So we first started using videogrammetry already 1 year ago. and we thought that this might be very interesting for certain applications. But the problem remained how to then georeference this kind of data. So in this video here, you can see here we had no additional devices. So we ended up getting models that were only generally georeferenced. We tried working with ground control points or some points measured on the terrain, but we figured that this might not be the most user-friendly approach. So because of that, we started looking into different options. Before we go into describing these different options, let's repeat where we believe that videogrammetry as a subject might be interesting. So primarily, we think this application is most useful for construction sites, where some infrastructure or something like that is being built. Why is that? Because we believe these are the things where having a quick mapping technique allows us biggest benefits. Because very often as surveyors, when we get out into the field, into the construction site, we might be there too late, we might be there too early. We need to map it fast. We don't necessarily have the time to set up the drone, or we might not even be allowed to fly there with the drone. So as a second topic where videogrammetry might be interesting is for mapping areas where drone flights are not allowed. So depending on where you live, that might be in dense cities or something like that, or close to the airports, for example. We also think that it could be interesting for quick volume measurements, where we have some pile of material on construction site and we want to map it. It also proves interesting for use in indoor mapping, but indoor mapping might be a little bit tricky because indoor, it's very important to have very good lighting. Otherwise, the video, it will be grainy, and that doesn't work so well for the videogrammetry or photogrammetry applications. And finally, where we think it's interesting is where we have to do any kind of documentation. So for example, if we need to document where the telecommunications cables are, any kind of documentation, we think videogrammetry is very interesting because we just record the video quickly with it and later process it in the office, and we get a 3D model, allowing for better documentation than just measuring a few points with, for example, a total station or a GPS receiver. So for that purpose, we developed a special Android app, which along the video also records GPS telemetry. And it stores this GPS telemetry in the video itself. So we developed this app with the goal of achieving automatic georeferencing for our videogrammetry projects. Of course, this app will work best if along with this app we also use an external RTK GPS device. So for our work, we tested the device which is called smartphone RTK. So here below you see two websites. So we first learned of this smartphone RTK through a company called RTK. They sell it on their website. The basic price is 400 euro. They also sell more advanced versions which include also battery pack for it and better antenna and stuff like that. The device is actually produced and originally sold by a company called Ardus Simple, and you can also order it if you want to test it through this second website as well. So the full price is 400 euros, and then there are some additional add-ons that can be bought. tested, ours actually costed 680, but I'm not sure. I think the prices changed slightly. So if you decide to check it out, check these two websites out and decide for yourself where you want to buy it. Okay. Now, at this point, I would like to hand the words to my colleague Mattia, who will describe how he and our colleague Marco use this device to map this small construction site. So, Mattia,
thank you, Vid.
And I will start the video now.
Okay, thank you. In the meantime, I got my camera working. So as you see on this video, we're at the construction site and we want to do some quick documentation of this ditch that's being dug. So we first initiate our client, and when we get it working, when we get the RTK connection, we can start recording. And for the recording itself, it's important to note that you have to walk slowly and steadily. Hold your camera as firm as you can. Don't make any sudden moves, and keep in mind, look at the screen what you are recording. You have to have at least 60 or better 70% of overlap. And if possible, don't go like Marco here, that's going one way down and the other way up. That's not wrong, but if you do that, try to do it again in the other direction. Here's the example of point cloud we got. It's pretty good. And it took us about a minute or a minute and a half to get this recorded. Okay, that's about it. And now we'll go over some basic principles how not to do and how to do things right. So the first thing I would like to point out is don't rotate your phone while moving. You have to rotate it slowly, and especially important, don't rotate while standing on one spot. Imagine you're towing a trailer and you can't really turn it on the spot. You have to go back and forth, something like that. So the next thing would be, don't wall paint. What I mean by wall paint is like going up and down with your phone like this. This will give you bad results because you're getting a lot of images, but they all have the same coordinate. Okay, and the next principle is, as I said when we were watching the video, move slowly and steadily. One thing you have to know about if you're recording this way, our application does not actually turns off all the stabilization that is built in your camera. That's because we need clean, undistorted photos to process. So keep that in mind. You don't have your super stabilization anymore, so that's why you have to walk slowly and steadily. Okay. And as I mentioned, it's best that you do connected loops. If you, for example, do a snake like here, that isn't the best practice because you may get some discrepancies in height if you don't close your loops. So when you're going around, try to go one way and then slowly turn around and go back the other way. This way you will connect the recordings and you will get double check on heights, and it generally will produce more accurate results in if you don't do that, you may get some discrepancies like a double sidewalk or a curb or something like that, and well, less accurate result. Yeah, the one more basic principle is get enough overlap. As I mentioned, 70% is best. Here on this picture, you can see on the left side, this is an example of good overlap. In the middle, it's not okay because these 2 point clouds now will not match properly. And on the other side, on the right side, it's okay again. So keep in mind that everything you record should overlap and you will have best results, best accuracy. And okay, another situation that is perhaps a bit tricky is how to approach corners. As I mentioned, when you get to the corner, don't just rotate on a spot, but try to go back and do a semicircle or a quarter of a circle and continue back on the parallel line like it is shown on the left image. And even more complex case here. It is very difficult for a photogrammetry program to match images that are, for example, shot like in the right picture. That's why you have to connect those in a semi, like, or quarter of a circle lines that that form a smooth line which has enough overlap, doesn't have sudden angle shifts, and yeah, and doesn't get interrupted. So try to imagine going here from A, you go parallel to the wall, and then you slowly turn for 90 degrees while walking forward, and then you get to the point C, then you go back a bit to point D, while you also again change the direction of recording for 90 degrees, and then again maneuver to the point F. But this is really advanced example, but you may find yourself in such situation very quickly. So there you have it. Okay. Now it's back to Vid that will show you some practical examples of sites that we have already mapped, and you will see how it came out. Okay, Vid, thank you.
Thank you, Mattia. Okay, now let's minimize this presentation and let's go into 3Dsurvey. I have here already prepared the special version of 3Dsurvey. Later, there will also be a link where you can download and install it. Right. So now, in this example, we will look at how we import video with this new version. So, as we showed last year, we will press. So, if you have this new version, it will say up here 2.17 scan 1.6. That's our top secret name for it for now. Okay, we will click here, images, extract images from video. Now I will navigate here to my small example. I have here a video that I will now share with you. So this one was actually recorded by one of our customers during our beta test that we did here at our office. So he saw this shaft here and thought, wow, it would be a great example for the use of videogrammetry, and it really was. So he just opened it and recorded this 40-second video. Now we will start processing it. I will select it here. Before we said that we have this automatic or FPS function. It turns out that this RTK device, it can manage to write the GPS information once per half a second or once per second. There are some limitations due to the speed of processor, how much energy the Android phone processor can use. So because of that, we have here a new processing mode, which is called telemetry. That telemetry mode means that it will try to select video frames that are closest to the point when when we receive new telemetry GPS position. So here in this case, I advise you to set it to telemetry and then see here, if you get about double the frames as your video is long in seconds, use telemetry options. Otherwise, go with the automatic approach. Okay, we will now press OK, and the extraction will start. So this process will now take about 1 minute or so. It's now extracting all the frames from the video, just like it did before and just like I said earlier. So for each image, so it's trying to take those frames where we received the new position. So unfortunately, this is now I'm here in my shaft folder. Let's leave it for this additional 50 seconds for it to complete. Let's see what's happening. So actually now we are overwriting the images that were previously extracted. So in this case, we could actually even stop it, but I will just now let it finish. Now, let's go back to my presentation. Now with this approach, I have here a photo of how our device looks. So here you see that we have this antenna and here we have our camera view. So now when we use this device, we will have some offset between our antenna and our camera. And in order to get best accuracy out of this device, it will be best if we can measure this offset. So the coordinate system that we use in this case, we measure how much the camera is rightwards in relation relative to the antenna, how much it is forward, and how much it is downward. So I always place the phone in so that the volume button is just next to this thing which holds the phone in place. So that way I can put it in always in the same orientation and with the same approximate offset. And then I just use a ruler to measure this offset with an accuracy. I try to measure it with a millimeter or half a centimeter accuracy. If your phone has multiple cameras, like mine does, then to best figure out which camera you should measure to, just start the Videogrammetry app and place fingers over the cameras. When you lose the picture, you will know that you are at the correct camera. So mine is the first one. And when we measure this difference, we measure from the antenna to camera. So in this case, the rightward value will be negative. Forward value will also be a little bit negative. This one will actually be probably similar for most of the phones, and downward value will also be negative. Okay, in the meantime, while I was speaking, this thing has finished processing. So here are the frames that were automatically extracted and latitude, longitude, altitude informations. So the GPS device, it actually reports the accuracy of about 1 centimeter. So because this position is calculated once per second, to be honest, I have a feeling that we get slightly better results if we manually lower this accuracy slightly. So we will do that later. But here, as usual, it's important now to select the correct coordinate system and correct geoid model. The vertical coordinate system, we will press now here import. So this data was now successfully imported. And now this will probably be the first time where you have to use this button, GPS INS to camera offset. So we had this scene for a long time now, but with RTK Videogrammetry, this thing becomes pretty useful. So here I can now enter my values. So I actually have them written here. So forward, I am at -3.5 centimeters. And rightward at -8. -3.5. And the easiest way to do it, place the mouse in here and just rotate the mouse wheel. And downward, we are at 7.5. This one will usually be a plus. 7.5. Confirm. Now I will also manually set precision, and I will set it to 4 centimeters for easting, northing, and elevation. Like that will be fine. Press confirm, close. Okay. Now, for now, the camera parameters on this one are not very good. So these are just initial camera parameters that we guess. We don't have any information on the camera, so we just set the focal distance to what the image width is. Probably it will be fine. Later I will show you how to extract those parameters and save them and use them in future projects. But for the first one, we'll just leave it how it is. Now we will go into bundle adjustment. For this videogrammetry, I see that it can be useful to set feature detection level to high. Other things, we can leave them how they are. We can turn off automatically using telemetry data for orientation, but lately I've been seeing that this auto options still works pretty well. So in the instructions that we will send you, you will see that it says you can set this one to no. Actually leaving it by default on auto is also fine. So here we have now 80 frames. So the processing here would take approximately, I think it takes 2 to 3 minutes. But in order for us, because that would be too long to wait for all of us, I will just go ahead and I will open a pre-calculated bundle adjustment project. So here is our sparse cloud now for this project. So you can see that that our customer Igor made this spiral recording, zooming in on the inside of the shaft. Reprojection errors that you should expect from videogrammetry will usually be between 1 and 1.4 pixels. So reprojection errors here are slightly larger than they are in the case of drone photogrammetry. Now, important step, once you process your first project, go here into camera parameters and click here on optimized, you will see here the camera parameters that were calculated. Click on this save button and export those camera parameters into external file. Press save. Then when you start a new project, right after the images are imported, click on this one, load camera parameters, and load. So then the initial camera parameters will be set to these values. And this is actually a very important step because if we have more accurate initial camera parameters, the bundle adjustment will run faster. It will produce better results, more accurate and less chance for any kind of error. Okay. Now we would continue processing this project normally. So now we would go to reconstruction, and then we would go to mesh calculation. Again, in order so that we do not wait too long, I will just go and press and open a pre-calculated project. And here it is, and let's have a look at now at this point cloud. So in this case, where we have this kind of small objects, double-clicking somewhere, moving the camera view there is very useful function because it allows us there then to better visualize this part. So here we now have this small shaft, and here is also a mesh of it. Like that, everything is loaded. And so this is now the 3D model that we got from that 40-second video. For this one, we actually measured also some checkpoints. Now the main question will be what kind of accuracy we can expect from this kind of application. So our hope was to get accuracy to around 4 centimeters, but it turns out half of the time, I would say we get a very good accuracy, 4 centimeters or better, but half of the time we get between 4 and 10 centimeters, for example. I have here now some projects, and I will open another project which one I used for assessing the accuracy of videogrammetry. I think that will be this one. I need to save that one. And in this example, let's also open the video first. Let's see the video. In this video, you see that I have sprayed some markers on the ground, and I measured these markers twice with an RTK GPS. So then, for the accuracy assessment video, we walked up and down this parking lot over those markers. Okay, that will be enough of the video. And let's have a look at the sparse point cloud now. So in this case, we moved in a W sort of manner to cover the whole parking lot. And because we were assessing accuracy, for this one, we left the cameras facing one way. So this one was actually mapped by one of our customers. So here we can see, in this example, the camera was facing slightly more forward than down. So I think we even get slightly better results when we rotate camera slightly more downward than forward, but not too much, of course. Okay, let's have a look at the point cloud. So here is also our point cloud, and here are our 3D markers. So in this example, we got a pretty good accuracy so the accuracy here was about 1 centimeter horizontally and 4 centimeters vertically. So here, this one again, this point was measured twice. We can go into CAD, add measurements. We'll be interested in 2D distance and delta height. Select a point here and place it here in the middle of the marker. And here for this one, we have 4 centimeters horizontally and 3 centimeters vertically. I repeated mapping this workflow with a few different phones and at few different times. My experience was sometimes it would fit to about 2 centimeters. Most of the times this would be around 4 to 3 centimeters, but there would also be time where I would get a 10 centimeter error. So this error would usually be homogeneous. So that means it would be same for the whole project. So that means if we obtain this kind of error, we can go here, and if we have some points to assess it, we can then go into point cloud, right click on it, press transform, and then just increase the height by, for example, 3 centimeters, and also move it vertically and horizontally. So actually, in the next version of 3Dsurvey, which will be out in about 1 month from now, there will also be a chance, there will be a new function, which will have here in the transform tool, a new button where these parameters will be calculated based on some points measured on the ground. But I'll leave that subject for the next webinar where we'll be introducing the new version. But just to let you know that there is something coming here for this subject as well. Okay, press cancel here.
Maybe just a question, now that you're talking about accuracy, you can explain for those who didn't understand, why did you adjust the accuracy manually in the previous case when you imported the telemetry?
Okay. So the RTK device, it reports accuracy of around 1 centimeter most of the time. That's a very highly accurate GPS. From my experience, I think that even the big GPS's accuracy will usually be around 3 to 4 centimeters. So I believe that that accuracy is calculated basically that the GPS measures its position for a while. And what I think happens is it takes its position and calculates standard deviation of the last few positions. And it reports that as its accuracy. But that accuracy might have also that accuracy in absolute terms might be slightly lower. So I know I signalized a point outside and measured it a few times with the GPS, and I know that sometimes the GPS will say that you have a centimeter or 2 accuracy, but my GPS position will be off by a few centimeters. So this RTK device, it has a smaller GPS antenna, a smaller chip, and it only records position once per half a second. So because our frames will not be at that exact time, we will interpolate slightly. So I think that because of that, it's actually better if we lower that accuracy slightly, so that will allow cameras to move more. So this thing, we are still testing it out a lot. So we are not 100% sure what is the best workflow to use, if this is even something that we'll end up using on a daily basis as we do use drones today. We think it's interesting, so and for now we're testing it like that. So usually I just decrease the accuracy there in that step, and now I think that's the better results.
To summarize, it's more realistic estimation of the error than what the device gives you.
Yeah,
Okay.
I would say so. Okay. Right. Now let's look at another project. This one was also received from our client Igor from the company Odmira. Now this one is interesting because for this stone support wall structure, he also placed some ground control points on the ground. So he tried to map this nice ground support structure with 3Dsurvey. And here in the point cloud, we see that he also had some points. Again, in this example, the accuracy was pretty good. So here there is, I think this is a border stone, and the accuracy on it was around 3 centimeters. Here he measured a shaft, and again, it fits pretty perfectly. Even and then some points here as well. He repeated this one for the second time. And this time, he even included the ground control points here. With ground control points, the accuracy increased, of course, significantly. So he printed out this kind of ground control points. And now let's go load cat. And let's import these checkpoints. And on these checkpoints, now if we check our elevation here, it's actually we get a centimeter accuracy on this border stone. And here 53. So the point cloud is at the exact same elevation as the point measured with the GPS device. Of course, important thing to note, probably the ground control the checkpoints and ground control points were measured at the same time, so that will help us as well. Otherwise, I would say a nice, interesting project for making a very detailed 3D model. So from drone photogrammetry, this kind of small details would probably be hard to obtain. Okay, let's have a look at another project. So I wanted to include also one where accuracy will be slightly less perfect. So for this area here, I went out and I mapped this construction site 4 times. So there was a part of road that was closed here close to our office, and I thought it's a great opportunity for me to go in and try our new videogrammetry technique. So this, I guess, was my first measurement that I obtained. I went in and made second measurement, then third one, and fourth one. Fourth one is when everything is filled up already. Okay, that's fine. So this one will not be that interesting, but these 3 are interesting. If we now focus on this corner, so we can see that here we have now a slight offset between these 2 points. And the largest offset that I was able to measure here was approximately 10 centimeters. I go here and measure 3D distance between these 2 points. Well, okay, it's about 7 centimeters, something like that. So what I would say pretty good for most construction projects, for documentation projects, but for surveyors, these 7 centimeters might be on the limit of what is acceptable. So this is the measurement, the second measurement, it's already closer, and here is the third measurement. So what we could also do is visualize all these three, use the select tool, and now the points are colored in different colors, a bit maybe psychedelic, I would say. Okay, let's press clear. I think we have to hurry things up a little bit. Again, we are taking a little bit too long. I will just go now to my last example. Project open. I have this nice one where I compared videogrammetry and the drone survey. Comparison like that.
And while we wait, we still accept questions if you have any. We'll try to answer them as they appear or in the end. Okay, go ahead.
Thank you. So this area here, here you see I put a lot of checkpoints in to check it. So, and I just made very fast mapping with videogrammetry, focusing on these two corners. Again, the accuracy that I, in this case, obtained was pretty high. So here around 2 to 3 centimeters accuracy in elevation. So you can see here, I measured the point here with GPS, and there is in photogrammetry. And here, one thing that I did note that is interesting for me in this example, if we go into point cloud view, you see that I focused on this spot and on this spot here. Here in between, we had not enough overlap. You see that I obtained this kind of an error here, where there was less overlap. But what was also interesting for this one, I combined this videogrammetry with my drone survey. So if we combine these two together, we get pretty nice result. With drone photogrammetry, we get slightly lower density, and here where we focus with videogrammetry, the data is a lot denser. So this data can be joined and merged together. Right, not to take too long talking about this one now, I would like to go now back to my presentation and also spend some time describing how to use this, how to install this application and how to best use it. Where are we? Camera parameters. Okay, so this webinar is being recorded, so you will be able to go back and look at it slowly. So if you want to test videogrammetry on your device, first you will need to set up your drone or your phone properly. So that means that you will need to enable developer options on your Android device. To enable the developer options, you need to find about your phone section in the settings. There in the about your phone section, there will be a build number. So you will need to tap this build number 7 times. You just click tapping on it here like that. And then it will say you are 1 tap away from becoming a developer. And then it will say, it might say, enter your pattern or enter your PIN to enable developer options. Afterwards, you are a developer. Then you will need to install 2 apps on your phone. So first one will be it's called Lefebvre N-trip client. So this one allows connecting through N-trip. And the second one is our 3Dsurvey Videogrammetry app. So you can simply scan these two QR codes with your phone and you will automatically install them. Then, after the N-trip app is installed, you will need to go into developer options and select mock location app there, and you will need to set that mock location app to Lefebvre client. That mock location app means it will allow Android system to use location from the Lefebvre N-trip client instead of the default GPS chip. Right. Then next step, you will need to turn on your RTK device and connect to it through Bluetooth. So the red catch model uses a pin. Pin for it is 1, 2, 3, 4. Luckily, when you try to connect to it through Bluetooth, the system itself will tell you that 1, 2, 3, 4 is usually the pin that is used by the devices for communication. So pairing the device through Bluetooth will enable us to use it. Then we need to set up our N-trip app. So start up the Lefebvre N-trip client, and there inside you will see this settings button. Press on that one. This will be the settings that we will be looking at: display settings, receiver settings, N-trip, and that's it. Let's look at the receiver settings first. In the receiver settings, we will set the parameters. So receiver configuration, we will say external via Bluetooth, and then we will select RTK red catch Bluetooth device. We can leave it in unsecure. Offset, we take cover of in 3Dsurvey. We can save GPS data to external file, yes or no, it's not important actually, but it is important to then enable GPS mock location, because that will allow sharing location to our app. Right, then the N-trip settings. So here we use the N-trip data the N-trip login that we also use for our drones. So we don't have a separate subscription for the videogrammetry, we just use the same one. And in here, what's important is to insert the N-trip settings. So this is our IP address from the service that we use. For yours will probably be different, and you just enter the port, username, and password. So this can be the same as for your GPS or your phone RTK, drone RTK, if you use that one. After you enter this for information, press on data stream, and then you will select like VRS, so virtual reference station, or you can select which reference station to connect to for GPS corrections. And then in the display settings, we can, for example, click on this one, show info boxes 3 and 4, and then we can display what kind of information we want to display there. For example, I like to display correction age. So that means how many corrections, how old the corrections that we receive are. There we will see it will say half or 1 second. It's very useful to show the 3D RMS, that means residual mean square, that means the accuracy that the GPS is reporting. And we can also display elevation or GPS time or something like that. So these two are actually not that important. Set it to whatever you like. Afterwards, our settings are completed. In the N-trip client, we press here on the connect button. Before we connect, it will say connect. And then it will say, okay, we are trying to connect. Fixed type is now GPS. Then it will say fixed type is now float. When it gets the best signal, it will say fixed type is RTK. And up here, it will also say RTK. What's interesting about this, actually, even if there are more satellites, then 12, this app will say there are 12 satellites. So we check this thing, it actually is like that. So for example, if the app uses even 20 satellites, here it says 12. So when I work, I like to wait until this one here says 12, and then I know that probably we have a good enough accuracy, and then we can get to working. So then we start our videogrammetry app. This is how our videogrammetry app looks. It's basically just a video recorder app. It has two things. Here it has a record button, and here it also says what kind of GPS accuracy the entry client is reporting. So we wait here for it to say that we have a centimeter or two accuracy. Once we do that, we can press record and we start recording our video. Once we are done finishing recording video, I then upload it to my computer and then I process it as we explained at the start of this presentation. Right. So this was our first webinar on the RTK Videogrammetry topic. So now will be the best time. We will look if there are some questions on the topic.
Yes, we have some questions if you would like to dig in.
Yeah.
Want me to help you or will you find them?
Yes, please. So I'm opening the questions view now, and I see that the most popular question that we usually get is webinar being recorded and can we get a copy? Hi, John. Yes, our webinar is being recorded, and I think by tomorrow it will be uploaded to YouTube. So the second question.
Some of these are already answered.
Yeah, I see. But there was a question: is are the measurements in centimeters or in meters? So by default, if 3Dsurvey is set to metric system, all measurements are in meters. But then I just look at the last digits. So it will say 0.07. That means 7 centimeters. There was a question. Do you recommend to shoot video from hand or can we use gimbal? Because you said the video has to be smooth. Yes, gimbals are perfect, but you will need a very large gimbal if you will want to use the RTK device with the gimbal enabled. So we had one gimbal in our office, we tested it, but it was not powerful enough to stabilize both the phone and the RTK GPS antenna. There was a question from Steven who asked, is there mobile RTK unit currently available or still under development and how much it will cost? So I think the mobile RTK units are more or less developed now. We are developing the application for it. So we are still developing 3Dsurvey algorithms to make best use of it. How much will it cost? So this device from Arduino Simple or Red Catch, you can get it from 400 euros onwards. So I think it will be either 400, 480 with the added battery holder, and I think they also have one for 680 with some improved functionality. There is a question from David. If we would not use video and just take photos with camera, would we expect better accuracies? You can also just use photos from camera, and you can, if you set your camera up so that it stores the GPS location, it will actually, and if you use the N-Trip client app, you will actually get RTK positions for your shots. I wouldn't say you will get better accuracy. So when we test based on my feeling, we get about the same accuracy with photos as with video, but with photos, maybe we would be more likely to get into a situation where not all photos will be registered. Now there is a question from Brian. So if you are collecting data outside, it works nice. But what if you partially lose connection to GPS if you walk under the roof or inside of the building? Yeah, so this device will still report the position. Actually, we find that it is slightly tricky because we saw that even after we moved under the building or inside, and we would expect the device to already lose the position, it was still reporting good accuracy. So that also led us to believe maybe not to trust that accuracy so much. So I think this is actually a little bit tricky, and for those devices, I would probably, if I then had the need to process that project, I would try to remove the telemetry for those devices. So the current version of 3Dsurvey actually allows you to do that. It's basically a hack, but if I show you here, it would be possible to delete the telemetry for those files. So, and that if we deleted those telemetry informations, then they won't be used, but 3Dsurvey would still reconstruct those images. So I'll just go here. I will show you how 3Dsurvey actually processes it. So in this folder with photos, 3Dsurvey will actually create this TXT file. And in this TXT file, there will be coordinates and there will be accuracy. So for the photos where we would lose the GPS accuracy, what I would do is I would just select this and press delete. And that way I would delete those values. Or instead, we could just increase the accuracy here. So for example, we could say, I don't trust this accuracy, so for these values, we will set the accuracy to 3 meters instead of 1 centimeter. So that would also work. So yeah, there are solutions to this problem, but they might require a bit of like hackish approaches or something like that. Then the next question, is this only available for Android and not iPhone? Yes, unfortunately for now, we will first develop the app for Android, and after we are certain that this is what it is, we also plan to develop the iPhone version of the app. The next question, I have 8-inch Android tablet with internal RTK. I think will work also. Yes, Helmut, go ahead and test it. I think it should work just as well. So you might not need to enable, well, yeah, I think you will also need to enable the mock location so that the GPS location reported will be the one with N-trip applied. Other than that, it should work as well.
Let us know, Helmut.
Yeah, good one, Mattia. Is this RTK device could be used with drone? I think that the producers of this device, they probably also have some specialized solutions for the drone as well. Check the Arduino Simple website in this example. They might have something there. Is it possible to work with videogrammetry also with our DJI 4 RTK instead of smartphone on separate GPS and your app? Thank you. The DJI Phantom RTK has an option to record video, and it will even record the telemetry information into the subtitles of the video. But we actually tested this one and we found out that so it will report So there the subtitle lasts, I think, 1 or 2 seconds, and we don't know which time frame that position is referring to. So I tested this with data from, I think it was from Matrix and from Phantom RTK, but I couldn't get a good enough accuracy from them. So I would say probably not, because we are lacking the ability to join together accurately the telemetry information and video information, because they are in two different time coordinate systems. Okay, and I think that was actually our final question.
Yeah, that is all.
So, perfect. So I would like to thank all of you for joining our webinar. Very glad to have you here and looking forward to meet you again on the next one, where we will be probably looking into the new features that are being developed right now and should be released in about 1 month time. Thanks again for attending.
Yeah, thanks also from my side. Join us next time. And yeah, we'll be
happy 3D surveying. Bye-bye.
happy 3D surveying. Bye.